nonsense.
Nonsense. You just said you were gonna go see it, you liar.
Oh,
They're
yeah.
gonna be figuring out time code.
All right, I guess. All right, so this is a 3. W. It's a 3.
Yeah, I thought it was.
This is a W right
Oh.
Is it? It's like a bird.
here. W. Right there. W. It's a bat now. Okay, so I'm not going to ask for the domain for this type of question, so I'm not going to do that part. But I will ask you to plug in values to something similar. So it will be on your final, very similar. So please don't miss this. So F3, that means just plug it in, right? Reduce it. That gives us square root of 4 over 3, which is 2/3. That's all you have to do. F of W minus 1. Same thing, just reduce it. You get square root of W minus 1 plus 1 over W minus 1. So that'll give us square root of W, the ones will cancel, over W minus 1. So that's all I'm going to ask for number 1. Any questions on the first problem from exam 1? Straightforward, right? Okay. Find the average rate of change. This is question 2 on exam 1.
How many questions do I make this exam?
Like 12 or so. Like 12 or 13 problems.
How many from chapter 7? Since we just went over.
A few.
No, right?
3 maybe? I don't remember. At least 2. At least 2. Okay. Give find average rate of change of f of x equal to x to the 4th minus 4. The average rate of change formula is equal to f of b minus f of a over b minus a. So plug in, so I'm going to put parentheses on my first function, the b, plug it in the b. And the a and b are going to be 2, b is 4. Okay. So just plug them in. 4, actually, no, I think it's 2, I'm sorry. Just so they're not too big. So then it'll be 2 to the 4th minus 4 over 2 minus 0, and then minus the function at 0. Okay. Let's make it right over here. So 2 to the 4th, that's going to be 16 minus 4 minus a negative 4 over 2, which is 16 over 2, which is 8. Any questions on these values? Is that okay? That's question 2. Question 3 was given a piecewise function graph x plus 6 if x is less than -2, x squared if x is greater than or equal to 2. Okay, so what I recommend is plotting around that boundary point. So let's pretend you are allowed to plug in -2 into here. If you plug into that first function, you're going to get a negative, you're going to get +4, right? So -2 into that first one will give me a 4, but I'm not allowed to actually use it. So I put a hole there. If I go lower, -3 into here gives me a +3. So that would be right there. So technically I have a line going this way. I just need 2 dots to connect them. Who cares? Are you comfortable plotting these numbers, these values? I didn't show that step here. Do you see where I got these points?
I see how you got the 5 through
X is chosen by you. You choose whatever you want. Of course, you need to work around the boundary, so that's your starting point.
So you can't use -2.
I can't. That's why I put a hole. But if I could, it would be 4, right? So hole there as a placeholder, just so I know that where it kind of ends or starts. Okay. But if I were to use 2, it would go in here. So 2 squared is 4. So technically the parabola is defined there. And if I plug in 0, I get 0. So I have a problem doing that. Plug in +2, I get 4. So technically the parabola connects through there, goes through 0, and then keeps going forever. Okay. So you choose whatever points you want. So for f of x equal to x squared, 0 gives me 0, -2 gives me 4, 2 gives me 4, right? That's where these points came from. This one, this one, this one. Now, if I were to use the other one, if I plug in -2, I get a 4, -3, I get a 3. That's why I got these points. If you want to see the scratch work. Any questions on the graphing? The exam also said find f of 0 and f of 2. So f of 0 means you have to use the parabola. Actually, that should be minus right there. The parabola. Because 0 is not defined for the first term. So f of 0 means it goes into here, which gives me 0. F of 2, let's see what this question said. F of 2 would also be the parabola, to be 4. I believe that's what I asked on the exam, 0 and 2. Okay. Any question number 3? There's not going to be a lot of graphing on this exam, but if there is, it's going to be a piecewise. I don't really care about graphing that much. You guys cool on 1, 2, and 3? I'll turn the page in just a moment. Yes.
You said that we're going to continue this on Wednesday, correct?
Yeah, I'm gonna go as far as I can and probably continue on Wednesday.
Wednesday study it.
Right. So there, I can't force you to be here.
Okay.
If you want to come, you're welcome. That's cool in this picture. That's number 3, number 4. We may be finished today. I don't know. We'll see. Given f of x equal to the square root of x plus 2 and g of x equal to 1 over x. Oh, actually, that was just the overall stuff. Yes. Number 4, find g of f, which is actually equal to g of f of x. That means, which means g of the square root will get us to here. So there's g of f. That's all you had to do is plug in this guy into here. Okay. Part 5 asks for the domain. So when you look at it, you have a square root in the bottom, right? So I know I can't have negatives. Also, you have to worry about making the bottom 0. Do you see what x value will make the denominator 0? We can't have x equal to -2, so I got to put a parentheses there. Everything above -2 is fine, right? 0, fine, 4, 10, 20. Everything is fine afterwards. The domain would be this. It cannot be equal to -2. Even though the square root would be fine, we will get 0. Okay. So if you're wondering, like, how do I know this? Look at the inside. Determine when this is equal to 0. Solve for x, right? X cannot be -2. Anyway, does that make sense? Is there any question on this? The main stuff? Do you see why this is it? Just let me know. You could technically graph it too and see where it's at if you wanted to verify. Right. Okay. Number 6. Yes. 5 was the domain of g of f. 4 was just find g of f. Okay, 6. They gave you 2 functions and asked you verify that they are inverses of each other. I remember some of you just solved for inverses on each one and showed they were the same. That is technically okay. The official way was to compose them together. So if you do f of g, right, show that this becomes x, and then do the other way, g of f, and that should also become x. And if that happens, then you've proven that this is an inverse of this. Okay, so first do f of g. That means I'm going to plug this guy into here. So that'll be 2 times x plus 5 over 2 minus 5. Those 2's will cancel, giving me x plus 5 minus 5, which is x. So I've shown that one direction, we're good. So then you do, hold on a second. I don't know how it's zoomed in. Same. Okay. G of f is the other direction. You're going to plug this guy, this f function, into here. So that'll be, I'm gonna put it in parentheses so you can see it going in there. So that was my x input. So that'd be 2x minus 5 plus 5 over 2, which is 2x over 2, which is x. So since both of them end up being x, we've proven that they are inverses of each other. That's the process. Is there any question about that? Is that clear? Okay. I'll wait a bit. All right. Yes. Okay. That's cool on this page. I'm going to turn the page. Number 7. I ask you to find the inverse given a function. Given f of x equal to 1 over x plus 4. So the first step was to change it to y, right? So we said. Second step was switch the roles of x's and y. Third step was solve for y. So y is on the bottom. So we can multiply both sides by y plus 4. That'll get me to here. These will cancel. That'll get me to here. And we're trying to solve for y, so we're going to move that 4x to the right-hand side, then divide by x. That'll be our steps here. So x, y equals 1 minus 4x, divide by x, and we get to here. I skipped some minor algebra steps. Is there any questions on the algebra? Final step is you change y into f inverse because that is what we are looking for, right? That's what we're doing. So change to y, switch y and x, solve for y. Yeah, that's it.
Wait. Okay, so with, oh, never mind, I got it.
See it?
Yep.
Okay. So all this right here is just solve for y. Okay. Number 8 said, give me a square root function that is shifted to the left 3 and up 6. So the answer would have been this. I think I remember a lot of you gave me a quadratic for some reason. That's all you have to do, right? This does a horizontal shift. This does a vertical shift. That's what I recommend. Any other questions on this page?
Wait, what did you do with number 8?
Number 8, this is the answer number 8. The question was, give me a square root function that has been shifted to the left 3 and up 6. So this is a square root function that does that.
And for formula sheet, do we like?
I think one page should be fine. We're front and back. And if you really need a formula, you forgot, I'll put it on the board. Just let me know.
Would it okay if we had more than one? Like if we just used our formula sheets from the last exam, like stapled together or something?
Oh, yes, sir.
Yeah, that's if you still have them, that's fine. That's fine. I'll save you some time.
For Friday next Sunday, is it gonna be during this class period, or is it gonna be like?
It's well, actually it's on my calendar now. Let me see.
I want to say I read between 11 and something.
It's from 11:30 a.m. to 2 p.m.
Yeah.
That sounds right. Let me double check. Yeah, 11:20 to. Sorry, 11:30 to 2 o'clock. So you said right?
Just advance them, like,
No, I was double checking you.
you didn't trust me.
Do not. After something that serious.
Internalize this.
No, I have no feelings towards that stuff right now.
For what?
So it's not based on gender.
What?
My calendar.
Oh, I don't know why, but you're talking about the John Denver hurricane. I had no feelings towards that, and then my brain automatically went, what has to do with men versus women right now? Like that's, I don't know what, that's where I thought you went.
My master is logic. That's what I follow. What are the facts? And right now it looks like Amber Heard's in trouble, right?
The audio recordings are crazy.
Yeah.
Have you heard the Aquaman one? It's like yelling at him, he goes, Aquaman.
I have not, but I want to.
It's not like she's saying like, give me my wig back. So everyone's like thinking that she was wearing a wig when he said it. It's like make fun of her. Aquaman.
Okay. Before we get too distracted. All right. So
Alright.
number 9, the question said determine if it's even, odd, or negative. And I gave you
To the third.
yes, x cubed minus x. So determine if it's even or odd, and you had to plug in a negative x, and if it turned into, if it fit one of the definitions, you would just say even or odd. If it didn't fit either one, obviously you would say neither. The definitions for even was if you plug in the negative and nothing happens, that is even. A negative x though. It needs to be negative x because that proves for any x value. If you just plug in -1, that approves for one number, which is not a proof, right? It's an example. If you plug in a negative x and it's as if the entire thing swaps signs, that is odd. That is a property of an odd function. So you're looking for one of these. Plug in negative x. Right, so that's how you show it. If you cube a negative, that's as if it still stays negative. Negative, negative makes it positive. Do you agree that this is the opposite sign than this one, the original? Right, they're completely swapped. So that is the odd definition. If they swap completely, this is odd.
So the 3 stays up there. Above it.
Yeah, think about it, right? If you do it 3 times, negative x and negative x is x squared, but then another one gets me back to here. I didn't show that stuff, but that's what happens. That's why it's still minus. Okay. Number 10, I think was the last question. Number exam 1. do the same thing. Plug in negative x and see what happens. So it'll be negative 3x cubed plus 2x squared plus 1. Is this the opposite to the original? Is it the same? Those are the two questions you ask yourself. If it's the same, then it is even. If it is the opposite, then it is odd. Is it neither? Yeah, because it's not the same, right? And only one of them swapped. So this is neither. Not odd, not even. Any questions on 9 or 10? So those are all the solutions for exam 1.
We do an odd,
We did. Here.
I mean, the even.
Sure. Now let me make one up for you. Okay. So if you plug in a negative x, if it stays the same, we have even. We should remember that squaring any negative means it's going to become positive, right? This is an even power, which is the same property. It's like a square. So this should become the same thing we had to begin with. And the 1 is still a 1. So is that the same that we started with? So it is even. Okay. Any questions on exam 1? Moving to exam 2. Oh, second. Exam 2 is all the log stuff. I think I have it. Sorry. That's cool on that page, right? Exam 2 solution. So number 1 was combine the logarithm. We had 2 times log 5x squared plus 2 log 5y cubed minus 3 log 5z. So let's distribute that 2 first, and then bring up all the powers. Once the powers are on the top, you start combining the logs themselves. So multiply the 2 on every single term. Okay. 2 times 1, 2 times 2, 2 times 3. Now bring up those powers, but when you bring them up, you're gonna have to multiply times whatever is already there. Okay, so this will be log 5x to the 4th plus log 5y to to the 12 minus log 5z to the 6. Any questions on that step there? So here we distribute. Here we use the, I guess from here to here was the power rule for logarithms. Now combine these into a sum, the product. If you have a plus, that means you multiply. So you get log 5 of x to the 4th y 12th minus log 5z. Minus means divide, so our final answer will be x4 y12 over z6. We did product and then quotient. That was number 1. Any questions on the steps? Number 2 is expand the logarithm, the opposite. If I don't write the base, what base is it at? It's going to be 10, yeah. So assume it's a 10 if it's not written. This one was a base 5 the whole time. It didn't really make a difference, but sometimes it might. Okay. So first step, I would recommend to do the power rule. Here to here with the power. Up, and then we have a big fraction, so just do two logs that are being subtracted. So log of the top minus the log of the bottom. That is quotient. And in here you have a bunch of products, right? X, Y, Z, and WP. So use a product, you will get log X plus log Y plus log Z minus log W plus log P. So that minus is on the entire thing, right? So whatever comes out will have a minus. And at that point, we're done. Just multiply the 4 and distribute that negative. That'll give us 4 log X plus 4 log Y plus 4 log Z minus 4 log W minus 4 log P. Any questions on that? 2? Wait a sec. You got school on this page. Three. Solve the following. Log base 2 of 3 plus log base 2 of x is equal to log base 2 of 5 plus log base 2 of x minus 2. So they're all base 2s, 3 and x, 5 and x minus 2. Okay. So in the notes we said combine your logs first so you can start trying to cancel things. Here we have a sum. The first step is change that to log of 3 times x. Right hand side, we got a 5 and an x minus 2. So that'll be log of 5 times x minus 2. Base 2 though, I forgot. So at that point, you introduce the base to cancel your logs. Technically, you don't have to for this example, but it's a good habit to get into. Just in case you have a strange, like a whole number on the right-hand side or something weird. This will just take care of your problems. Okay, so then these cancel. And these cancel. So I'm going to end up right here. Solve for x.
What cancel the two?
The 2 and the logs are inverses, so they end up undoing each other. That's a property of logs. So at that point, just solve for x, right? Move the 10 over, move 3 over. That'll give us this. So x is 5. Technically, we should test if it works. So plug in 5. Is this equal? Yeah, it looks the same, right? So we're good. We could go further, but it should be obvious that this is the same. That we have equality, right? All right, that's number 3. Solution and testing the solution. Any questions on 3? The next one will be a exponential equation, not a log equation. You guys okay on this page? Solve e to the 2x minus e to the x minus 6 equal to 0. So I said that this was a quadratic type. I said let w equal e to the x. So we should see that e to the 2x minus e to the x minus 6 equal to 0 is the same as e to the x squared, right? You see that?
But I thought you mentioned the-
We will. But I want you to see before that substitution that this is the same, right? That way this sub makes more sense. Is that okay? So then you can just plug it in right there. And then start the factor. So that will be what? W plus 2, W minus 3. Set each one to 0. W is -2, W is 3. Bring back your exponential. And you should immediately see that this has no solution. This one does though. So exponential is never equal to a negative number. If you try to solve this, you will get an error on your calculator. Because you got to introduce ln to cancel the e. Okay, so over here you'd say ln of e to the x equal ln3. These cancel and I get my answer. But if I were to do that to a -2, you would get error. There is no ln -2. Okay. So we only have one solution. And you don't have to test it in exponential equations, only the log equations. So don't waste your time there. Any questions on number 4? Okay. It's cool in this picture. Number 5. Solve 3 to the 2x plus 1 equal to 5. So here we just introduce whatever log you want to use, doesn't matter. So I'm going to choose to introduce ln on both sides just because. So the goal is to bring x down. So I introduce ln in order to use those properties that allow us to bring powers down. So right here, you bring the 2x plus 1 to the bottom. Some of you just divided the ln3 out and just isolated x. That's technically fine. You can also distribute the 2x and the 1 on the ln3. It's up to you. So if I distribute, I get this. And I got to subtract this guy over here. But then divide by everything that's not x. So x will equal, well, let's show this step, I guess. Everything cancels except the x, so x equal to this garbage here.
Where did 2 ln3 come from?
This one? I'm trying to isolate x. I have a 2 and an ln3 on the x, so I divided that out. So they're gone. Or I should say they were canceled out. That's number 5.
So I can't just subtract ln5 and ln3 to get ln2.
You can't. This is similar to the rules of radicals. You can't, for example, do this, right?
So you get Oh,
Like it's inside an argument. Like if they were the same time, then you could combine them. Like if it was 2 ln3 minus ln3, that would be one of them, right? Like, technically, that would be fine, but they're all weird. But you see what I mean?
sure.
Uh, this would be 3. This would be a 2. So just treat it like an x and a y. They're just different. That's all. Apples and oranges.
Well, the argument makes, I mean, the argument idea makes sense.
Yeah, it feels like it should, right? Number 6 was a compound question. Any other questions? Sorry, you guys okay? Let me know, but I know these can be weird. Let me write the question down because it's important. If $2,500 is compounded daily with a future value of 2,500. Oh, this one was messed up. So let's say it's 3,000. After 3 years. So on the exam, I made a typo, so I gave you that question. You remember? So this time, let's fix it. What was the rate? So I got the future amount and the initial investment. In 3 years, if I made $500, what does the rate have to be? That'd be pretty decent, I guess. Let's see here. So the formula for compounding was A equal to P times 1 plus R over N to the NT. I solved for R for you. Remember, I gave you a list of simple formulas to use, so you don't have to do all the work. I don't remember them, so I'm going to solve for them again. A over P. Divide by P both sides, we get to here. Square root NT, or NT root to both sides, right? That's kind of weird, but that'll get me to here. Subtract by 1 and just multiply by N. So R will equal sorry, I had to redo the formula. I don't have the notes in front of me. I'm sure you have this somewhere. R is equal to this, right? So plug it all in. What is N? Compounded daily. So let's say 365. Time is 3 years. P principal, we started with, and A, the future amount was, okay. So we got everything else. Let's plug it all in and we'll have R. So this will be 365 times. I'm going to use the parentheses instead of that weird root because it looks strange. A over P, 3,000 over 2,500 to the 1 over ND, which will be 365 times 3. What is that? 1095 root minus 1. Either way, at this point, it's calculator time, right? Either way. So 365 times fraction 3,000, 2,500 to the fraction 1 over 1095. So the rate is huge. But that's the decimal. Be 364.06. As a percentage, that would be ridiculous. Yeah, it's ridiculous rate, right? The bank messed up and they're like trying to close your account at that point.
Nope, that's fine. You screwed up.
Yeah. I remember reading about that. Some couple got like, I think it was like $1 million or something ridiculous, like some bank error, and then they like started just paying off their house, paying everything off, and just like spending it right away. The bank was trying to come after them. So I'm like, that's
Honestly, that's how it is in real world. Find keepers.
yeah, like, I think that's on you, bank.
I feel like happened with someone's paycheck, they got paid like $60,000 on accident, they like quit their job, and they weren't able to contact that person.
Like good luck.
How'd you get to 10.5?
1095 is 365 times 3,
Okay.
because it's the it's supposed to be an NT root here. But I wrote it as a power instead. I think it looks a little prettier. So it's 1 over 1095.
Okay.
Okay, well, it makes sense, right? If you made $500 in 3 years, it's kind of good, especially if it's just a basic compound. Double check my stuff here though.
That's the case. I was $43,000.
Yeah, for sure. My life station in there. Right, goes cool and fixed. Yeah, the question was messed up. That's why the numbers came out weird, but it should have been some nicer numbers. Oh well. Happens. Give you guys free points. I feel like that's fair. Number 7, find the exact value of trig functions at pi thirds. Okay. So basically what they want is find sine of pi thirds, find cosine of pi thirds, find tangent of pi thirds, and then do the other 3, which will be cosecant of pi thirds, secant of pi thirds, cotangent of pi thirds. All right, pi thirds is 60 degrees, right? So sine would be square root of 3 over 2. So this is a unit circle problem. Cosine would be 1/2. Reciprocal would be this. Tangent would be sine over cosine, so you would divide these two. It would cancel out, giving you root 3. The 2's would cancel. Reciprocal would be this. If you were to rationalize, you would get this guy, and this would be this. Let's skip the rationalization step. All these numbers came from your unit circle. That box the best answers. I would technically accept this. Any questions on number 7? Great. What is the terminal and reference of 800 degrees? Basically, terminal meaning where does it land, right? They keep going around 800 degrees. That's going to be what? 80?
Yeah.
And if you're not sure what that is, what you should do is subtract 360. 800 minus 360, what does that give us? 440. That's still bigger than 360, so you do it again. 440 minus 360 gives us the 80. So this right here is the terminal side. That's where I stopped. Now reference angle, how far is that from the x-axis? Still, it's the same thing, right, in this case?
Always the same word.
No, it's always the distance to the x-axis. So in this case, we were over here, right? So how far are we down there? Well, that's the same distance I traveled to get there. When you're in a different, when you're in quadrant 1, it will always be the same as your question. Once you leave quadrant 1, you gotta look at it and see how far am I. Okay. To get to the x. So if I'm over here, right, some angle all the way over there, I only care about this distance. That's the reference. Number 9, what is the amplitude? Period. And horizontal shift. Y equals to -1/2 cosine of 2x plus 3 pi halves. Okay. So what I recommend is factor what you can of the inside part so you can get the omega. Factor that 2. Now I have x plus 3 pi over 4. Do you agree if I factor 2 out of this guy, it becomes a 4th? It's a little weird, but it's kind of like a backward factor. Whenever you factor something, it's as if you divide it by 2, right? So if you divide a half by 2, you get a quarter. 2 by 2, it's gone. All right, so what is the amplitude? always gonna be positive, whatever is in front of the cosine. The 1/2. Period. Cosine was 2 pi over omega. In this case, that is the 2. Sorry, shifting around too much. Yeah. So that this is the W, right? The 2. That's what you factor first, so you can see what's going to go on the bottom. All right, horizontal shift is going to be this number. Three pi over 4. Any questions on 9? All right, one last one. That's all we have time for. Number 10 is just arctan of square root 3. It was not meant to be difficult. Let's give the angle that does. I think it gives you a square root 3. You guys okay on this page? All right. Last question for today. Arctan of square root 3. So look at your circle. Actually, it kind of had the answer earlier, right? Check it out. Number 7. There's the answer right there. Pi over 3. Was an accident, but I gave it to you. Anyway, that's it for number 2, exam 2. Do you have any questions on number 10, like why it's 5/3? You see that we're looking at that circle, right?
Yeah, how did you get part 10? I mean, 10. I've been trying to figure out how to do the part. I can't figure out how to get that.
So basically, this is asking, what is the angle that gives me square root of 3? Right, this is the same thing that they're asking. So what you're going to look at is what sine over cosine angle would give me square root of 3. So that has to be, it has to be at 5/3. That's the only way you're going to get this. If these cancel. So this happens at 5/3. So whenever you're looking for a tangent angle, just look at your circle and divide the y by the x. And which one gives me root 3 when I divide it? Well, that's going to be 5/3 because I get this scenario. That make sense?
What if it's like not a pi number?
If it's not if I don't say exact, find the exact solution, then just punch in your calculator. That's it.
Because I tried to do it.
So 5/3 is 60 degrees, right? If you punch it in there, you should get 60.
This is our last class.
Most likely. Yeah.
Until the final.
Yeah, I might just post a video for the last group.
Chronologically, Loki is first.
Okay, okay.
Which one's first?
Loki chronologically.
I watched Loki this
Wait,
week.
we told you that. We were like, yeah, this is idiot.
But it also happens simultaneously. at the same time as